Hey everyone, my name is Ivan Kuznetsov. This is the first video in the channel that I have created, machine learning system design. So I am creating this video so that I can just put here all the different things that I consider important, and I just don't want to repeat those in every video that comes after that. So today I will just talk about a few things like who am I, what do I understand under machine learning system design, and a short summary of how I usually approach those problems. In general, we will be discussing machine learning systems, and I define systems design here as creating valuable machine learning systems, because in my experience I have seen quite a lot of stuff that was actually absolutely unuseful, where people would just treated machine learning as like money button and didn't really understand what machine learning can and cannot do, where it's useful. So valuable side will be one of the things that I want to talk about. Another thing is interview preparation. So there is a very specific thing that is understood under machine learning system design if we talk about foreign companies, and this understanding probably is like a subset of my understanding of machine learning system design. And yeah, those two things like interview preparation and creating valuable systems in the real world will be two main important parts here. So how will this translate to themes? A lot of my videos I plan to make around specific topics like design, Facebook feed, design, some recommendation system, stuff like that. And we will be doing some deep dives in specific topics. So now probably a few words about me and why do I want to do all that. I officially am machine learning engineering manager. In reality, I'm kind of like a tech lead. I still code. I build those valuable machine learning systems. I was doing that for quite a lot of years, but not that many. Still, like last 7 years, I spent doing some machine learning related stuff. Before that, I was also participating in some startups. And today I work as a machine learning engineering manager in a company called Turing, Turing.com. And just to be clear, here my opinions are only mine. And yeah, I also were interviewing for some fun companies. I in general interview from time to time just to see how I perform, and I was able to pass and fail some machine learning systems design interviews in Fang. So I passed, for example, Google for L5 level role, but I failed Meta for L6 level role. So I guess this puts me somewhere between senior and staff, but that's as long as we trust that these interviews actually are very informative about my skill. I'm not saying that my skill is actually better, it might be worse. So judge for yourself. And yeah, I guess now, why am I doing all that? My goal here is essentially just to learn stuff. I think this is Feynman's method, right? When you learn something and then you use your new knowledge to teach this knowledge to someone else. And that's exactly why I want to do that. I hope that there will be people asking me questions. I want no answers to those questions. And I will also have, it will be a lot of pressure on me to perform in this manner. And there is also a lot of pressure in usual interviews. So we can expect, I hope that it will help me also in the interviews themselves and in general learning how to present my ideas concisely, how to explain what I think, how to teach others. This is both interesting and I think beneficial. And I also, last but not least, I know quite a lot of good materials on system design, and this probably is a shout out to Hello Interview. I really liked this source in my interview preparation. Obviously, everyone knows about designing data intensive applications, and there are also other books. So, when you talk about system design, there are a lot of resources. If you talk about lead coding, it's just crazy how many resources are there. But when we talk about machine learning system design, there are a few books. I have read most of those books. I have read. I'm afraid to mispronounce her name, but Chip Huen's books, Designing Machine Learning System, I think it's called. And I also read Alex Su book by Go on machine learning system design. And I also am reading right now a book by Valery Babushkin on the same topic. But this is not enough. And I think there are not many good resources on machine learning system design online. Like, how do you actually prepare to those interviews? How do you pass those interviews? What are the expected? What is the expected structure? How should you reason? What things can you use that will help you during your interview? All of those things are missing, in my opinion. So I think there is a need for something like this. I'm obviously not sure that I will fill this need, but I want to participate in creation of some more content around how to build something valuable, because that's also another side. I think there are a lot of valuable software engineering systems, and there are also quite a few valuable machine learning systems, but as I said before, I don't think that resources there are spent in the most efficient manner. But yeah, without additional details here, let me also try to see how my iPad will be shown on the screen of my Mac, so that I can share with you the plan of how I usually approach the machine learning system design. Okay, I see that something is not working, so I guess I will need to do a few steps here. Okay, I hope to share my iPad screen through QuickTime. Obviously it worked before, now it just stopped working altogether. I have obviously no idea why, but yeah, it doesn't work. Let me just reload the system. Oh damn, I should have done this a long time ago, right? Yeah, those are the things that happen on the first try. I probably will re-record this now, but just to have something. Okay, screen, iPad. Operation could not be completed. I have no idea why. Okay, this doesn't work. Let me change my tech then. I will be doing screen sharing. Let me just open Excalibur, I guess. So let's create a new window here. Perfect. Let's do Excalibur. And now let's discuss what can be the plan and how I usually approach machine learning system design questions. Because many questions start with something like discussing loss function or whatever. I'm exaggerating a little bit, but it doesn't make much sense to me. So what I usually do, I start with problem exploration. And when we talk about problem exploration, what do I mean here? So first and foremost, I start with business case. A lot of machine learning systems have something like, okay, all machine learning systems should have some thing, some goal under the hood. And it, like, in some of the interviews, for example, in one of the interviews that I failed for Meta, the actual business use case was not very clear. And this is always a problem, because you basically need to make money doing this machine learning. And also, it's pretty costly to hire machine learning engineers. So at the scale of, let's say, fund companies, it usually makes sense. Then also, like, if you are targeting some specific use case as a startup, it also makes sense. But there are a ton of possible things where there is just like a very small edge that you can gain by doing machine learning system, and it doesn't work. So it's just like bad return on investment, because it's never guaranteed that you will be able to earn money doing machine learning. And a lot of the times you also need some fundamental things like data warehouses built correctly and everything, and like all the data pipelines. People just don't pay attention to that. But I think I'm already talking like in terms of 2020, year 2020 or something. Now it's a little bit better. But now we also are in the age of LLMs, so things are a little bit different. Okay, so business case is the first thing to discuss. Then I usually like to treat, okay, there will be a black box, right, that I'm creating, but what will be the input and output of this for this black box? Sometimes I don't do that. Usually I don't like the result of this. Black box means, for example, let's say we are doing a recommendation system, right? So in the recommendation system, what is the input? In the input will be, like, for example, user ID, right? And the output will be a list of video ID. Let's say we are recommending videos, right? And we can also say that it will be like 100 long, or however many videos we need to recommend, or like to store as a recommendation, whatever. So this is not the ideal definition of the black box, because then it also becomes, how do we deploy things? Because let's say we are doing predictions in real time. Maybe we just need to return top 3 videos, top 10 videos, whatever. Do we need to do pagination here? I'm going into too much detail, to be clear. When we are actually participating in the interview, we shouldn't go into too much detail here. But thinking about this helps you to formulate the problem, because let's say you're returning a recommended list. How many things do you need to return in this list? If the input is a user ID, how will you connect all the features to this user ID in the end? Like, all of those things, they help you formulate and like build a mental model of your problem. So then after we have that, it actually becomes pretty easy. So for example, if we have like a list of video IDs, right, then it's recommendations or ranking problem. Let's say you need to predict if someone will like score a transaction as fraudulent or non-fraudulent. Then there it will be like, what will it be, by the way? Will it be fraudulent, non-fraudulent as an output to another service? Or will it be a probability of the transaction is fraudulent, and then there will be some business logic on top of that? So are we delegating this decision to someone else? Because probably we should do that. Then it's like either or, like, what should we do here? So when you figure this out, it's relatively easy to now say that, okay, I see that my problem is classification, regression, recommendation, ranking, meaning problem. And that's a good point to talk about this. Afterwards, when you start discussing ML formulation, you can start discussing, okay, so this is what I want to do. How do I know that I do a good job about that? And then it makes sense to talk about both offline and online metrics. So I think it usually makes more sense to start with online metrics, like what connected back to the business use case. What is the specific thing that you think you need to do uh, to, what do you need to achieve to ensure that you haven't wasted the resources, right? What is the first simple step that you want to focus on? Basically, how to ignore all the less important things and focus on something. Then for offline metrics, obviously it will also depend on the mail formulation. If we are doing classification problem, we will be choosing some metrics. Otherwise, we'll be choosing other metrics. I don't want to go into too much detail. You also know all these metrics already. If you're here, I assume we will be discussing those in detail once we get to a specific problem. But in general, we also like connected back to email formulation, to business case, maybe even to the black box that we have created for inputs and outputs. Because, for example, let's say that in offline metrics, we are doing classification and we want to focus on recall or on precision, or we want to focus on both things, but maybe like false positives and false negatives are different in costs to the company or in benefit to the company. So then we need to somehow create some metric that will represent this idea of the business case when we are training the model. So when we are creating a model, we trained it, we need to figure out how will this translate eventually to the business outcome. And online metrics also should be connected to the business outcomes, like what do we track in real time so that we know that we are doing a good job. Okay, so this is the problem exploration. Once you do this, it should be pretty clear what to do next, right? So next, it will be features and labels. And here I always like to build everything around entities, but even before we come to there, some things that we need to consider, right? Like where do we start this problem? So it's one scenario if we already have a lot of history for recommendation, for search, for whatever, right? It's a totally different situation if you have nothing, and you need to start from scratch. So here we need to ask some questions about what kinds of the data is available. But when I say ask, I usually mean that we need to assume some things and talk to our interviewer if that's an interview, or talk to our stakeholders if it's the real world, and figuring out like what is the data available. Then another important thing that we need to consider is labels. It might make sense to start with this first, and there is a lot to talk about. I don't want to go into too much detail, but sometimes we do have those, sometimes we don't. What if we don't have those? How to create some proxies for our labels? Maybe should we spend some money trying to label the data ourselves? What to do there? Then the next thing is like entities that I started to already talk about. Entities are a very good way to think and to structure your reasoning around data. So for example, if we discuss, let's say, recommendation systems, then there will be user entity, but then there will be a content entity, let's say video, right? Then there will be also like user video interactions. So that's another entity. And like for the user, we can say like anything that relates to the user, usually is like demographics and maybe language, or several languages that we know that the user speaks or watches or whatever. Then it can be also like some geo information, stuff like that. Then about video, all the meta information, but then there is also user video interactions, and this will be like shares, like comment, all this kind of stuff. And then it can be that there are even more other kinds of entities, for example, like user or whatever. Basically, what I'm trying to say, it's a good way to structure that, because probably this data will stored in different places, and you will need, in real world, you will need to to figure out how to go about collecting this data. And then it also will connect to how you will actually serve your model, because let's say you have collected all the data just once, which is the easiest thing, right? You just dump the data in its current state. Then this might not work once you want to deploy your model, right? Because feature collection will be different there. Maybe you even need to optimize some things. Maybe some of those features are real-time features. Then there is also like time traveling and all this stuff that we need to talk about. Like, what if the user watched the video like a month ago, right? And by then, we recommended this video because we knew some things about this user, but maybe it was when the user just joined our platform, so we don't know much about the user. So what do we do then? Afterwards, let's say things changed a lot. So now user back then and user now are two different users, or two different vectors, as we can treat our users. So how do we get historical values for the user, for example? This is also probably something that you need to discuss later in the deployment part. You might need to discuss that. It depends on the problem, obviously, but here is where you create this connection to the future. Okay, so finally here we start to discuss modeling, and this is funny a little. I don't know, because people usually start discussing models somewhere like after business case or whatever. Like, I will create a gradient boosting decision tree. I don't know why. Why you don't even know what the problem is about, but you start discussing the modeling approaches. Even then, like, yeah, you can reason, consider different trade-offs. You have learned something about features by then. So I guess, like, to me, it always makes more sense to discuss modeling after we discussed all the features. And here it's usually a good thing to discuss some trade-offs. This is usually a sign that you're senior, because when you see a problem, you don't start using large language models for every problem, or even just like neural network for every problem, because some tabular data might warrant using just a simple gradient boosting, or even something easier. Or if let's say you have a problem that is not very hard from the data modeling perspective, right? From like how biased can you make your function so that it still works, but it needs to have a lot of interpretability. And this is a lot of, like, in many cases in real world, that's the case. And then like decision tree would work better. So yeah, those are the things to discuss here. Finally, deployment. I already mentioned some things about deployment. But here, one of the obvious things to discuss is like A/B testing. How do you deploy the model? It also depends on like whether you have existing model already in place. How do you decide if you need to change the model? And like, what kind of deployment do you want to make? Do you want to do shadow deployment? Do you want to do some canary deployment, blue-green deployment? All those kind of things that are usually only asked from, I don't know, software engineers. It's a very good idea to know about those things and to share what do you think will be the best solution here. Yeah, and I think that's it. Obviously, in my real videos, I will be discussing something else also. On top of that, I will be going into more details. And I also want to sometimes do deep dives, because I like to do that. For example, there is some concept that everyone already understands superficially, right? Let's say A/B testing. Everyone says A/B testing. I will just do A/B test. And about A/B testing, probably everyone already knows that this is a huge topic, very hard to understand sometimes. And maybe we need to do a deep dive there. Or let's say we have imbalanced target variable, right? Imbalanced data set. So that also warrants some discussions, or why imbalance is bad. because everyone knows that imbalanced is bad. Everyone knows that you shouldn't use accuracy, all this stuff. That's pretty like machine learning 101. But why? What would happen if you actually, maybe if you use accuracy, is pretty clear what would happen. But say you need to choose between row-Kauk metric or just recall, or recall in some combination with precision. Should you use F1 score? Should you choose different combination? That may depend on what particular class imbalance do you have. And then like the whole problem might depend on this. So yeah, doing those kind of deep dives makes sense to me. So I plan to do something like that. I also plan to not prepare too much to each of the videos. That's why I chose the format of streamings, so that it doesn't take too much time for me to create everything and to prepare everything. I just plan to spend about like an hour to prepare to each video, to be more to make it more of a format of me talking to you all in real time instead of just me preparing everything in advance and going over all this stuff. Maybe that's a bad idea, but I also want it to be a little bit like real or something. And this will also be in a way harder for me, but also in a way it will require less time from my side. So there is this benefit for me. Okay, so thanks everyone. I will just put it here. Okay, so I hope you all enjoyed this intro video, and have a nice whatever time of the day it is for you. See you next time. Bye.